And the last type of continuous probability distribution that I would like to discuss is exponential probability distribution. And here are some examples of exponential random variables. So, for example, length of time between emergency arrivals at a hospital, or length of time between breakdowns of manufacturing equipment. Another example could be length of time between catastrophic events like floods, earthquakes, etc. Or that could be the distance traveled by wildlife ecologists between sightings of an endangered species. As any continuous probability distribution, exponential probability distribution has got its own probability distribution function, which is calculated in the following way. So as you can see, exponential probability distribution has got a special term, theta, which is always specified a priori. And as you can see, mean and standard deviation are the same and they're equal to theta. So depending on the value of theta, you will get a different exponential probability distribution. So the higher the theta is, the flatter the distribution is. So vice versa, the lower theta is, the steeper the probability distribution is. And to find the area A, so this orange area to the right of some number A, for any exponential distribution, we use this formula. So we take e to the power of negative a divided by theta. So the probability that x, so the random variable, is higher or equal to a is calculated using this very simple formula. So let's have a look at the example. So for example, suppose that the length of time in hours between emergency arrivals at a certain hospital is modeled as an exponential distribution with theta being equal to 2. And our task is to calculate the probability that more than 5 hours pass without an emergency arrival. So in this case, this value that we are interested in, this a value, is 5, and we would like to know the probability that more than 5 hours pass. So we are to the right of the distribution. So we are interested in the area to the right of 5. So to calculate the probability that the random variable, that the length of time will be higher than 5, so we use the formula, this formula. So instead of a, we substitute 5, we divide it by theta, which is 2, and we get the probability of approximately 0.0821. So the probability that more than 5 hours pass between emergency arrivals is 8.21%. So the probability that no emergencies will take place within the first 5 hours is 8.21%.